Yo, what is going on? This is Mr. Martin. Check it out. We're on 3.3. We're going to solve some systems by graphing. We're going to do equations and inequalities in this lesson. Before we drew one line, now we're drawing two lines. Okay, so check it out. Our things to know. We got a system of equations in two variables that consist of at least two or more linear equations. We got to have at least two of them. Okay, the solution is the ordered pair that will fit all of those equations in that system. Okay, so if it does not work for all the equations, then it is not a solution. Okay, that ordered pair must work, meaning we plug in that x, we plug in that y, and we get true statements all across the board. Okay, for the inequalities, we're looking for what we call an overlap, the shaded region that will cover all the ordered pairs that would create true statements for all of our inequalities. And again, we're going to be using these half planes. Okay, it'll make a little bit more sense once we actually start cranking these out. Alright, so this first example we got, we're going to see some linear equation systems that have one solution. Okay, remember, just like with everything else, we might have some special cases. So as you can see, all of these are in standard form. We want to go ahead and put these into slope-intercept form. So I'm going to do this first one here in red. Okay. First thing we want to do is we want to write this down, and we want to solve for y. Okay. First things first, always get rid of that x term. Okay. Then we're going to drop down this negative y. Remember, we put our x term first. So here I got a negative x, and then I got a positive 4. Alright, looks good. Anytime the y is negative, we got to distribute that negative out, and we can do that by dividing every term by -1, and we're going to get a positive. Okay, -1 over -1 is going to be a 1 over 1. Remember, you don't have to write the 1 over 1. If it helps you, please do it. I'm just going to do it here on this example so you can see. And then we got 4 divided by -1. That's going to give me a -4. Okay, I am in my favorite form, slope-intercept form. Now I can graph. So we start with the y-intercept, always on this y-axis. Look at this number here, find that number on your y-axis, and we put a dot. Then we look at our slope. What is my slope? I got a positive slope, positive 1 over 1. Positive means up and to the right. So I'm going to go up and to the right by 1. Okay, I always want to put as many dots as I can, just so I can have a nice, good looking line. Alright, let's go ahead and draw this line. Boom. Alright, let me fix that up a little. Just a tad. Alright, there we go. Looks good. Alright, I'm going to do the second one here in green, okay, just so we can see the different lines. We got 3x plus y equals 4. Remember, drop that x term, boom, like so. Always do the opposite. Then we drop down the y, x term first, and then my y-intercept. Okay, look, my y is already positive. There's no need to go further. Okay, so if it's already positive and by itself, you are good to go. Alright, so we take a look right here, positive 4. I go up here to positive 4. What is my slope? -3. Remember, if you can't see it already, it is always going to be over 1 unless we have a fraction. But if it's just this whole number, we got to have that over 1. So we're going to go negative slope, which is down and to the right. So I'm going to go down 3, 1, 2, 3, and to the right 1. 1, 2, 3, and to the right 1. Okay, you notice how if we drew our line first, my dot actually lined up with this line. That means we're doing things correctly. You're going to want to see something like that happen. Okay, then 1, 2, 3, and 1. Alright, so let's draw this line here. And boom. Alright. Now that we got both lines, we want to look for what we call the intersection. Where do these lines cross each other? Looks like they cross right here. Okay, so this is my point of intersection. And I want to figure out what is the XY ordered pair. So I go over to here. That's going to be a 2. so a positive 2, and then I'm going down to negative 2. So 2 comma negative 2 is my solution to this system. So what that means is if I plug a 2 in for x and I plug a negative 2 in for y, I'm always going to get a true statement right here, that positive 4. Only this ordered pair will work for both of these equations. Okay, so this is what we're looking for. All right, I'm going to let you do the next one here. Go ahead and pause the video right now. Come back, take a look. All right, welcome back. So I ended up getting 4 comma 4 as my ordered pair. This is where they intersect. So this first one we converted, we get 1/2 x plus 2, and then over here I got a positive 7/4x minus 3. Okay, so hopefully you are good to go on graphing single lines. Now we're just doing 2 of them, and it's just a matter of finding that point of intersection. Okay, very good. All right, so we do have some special cases. Okay, there's 2 of them that I'm going to talk to you guys about. First thing we want to do is we want to convert, as we always should, from standard to slope. So I'm just going to run through this real quick, convert these up for you guys. Let's see, boom and boom. Negative 3y equals negative 5x minus 9. Divide everything by negative 3. Oops. Ugh. Sorry about that. Negative 3, there we go. And then we get y is equal to, remember, negative 5 over negative 3 is a positive 5 over 3. X always out front. And then I got this plus 3. Okay, so y equals 5/3 x plus 3. Let me box this up too. Alright, let's do this other one in green. So we got 5x minus 3y equals negative 3. Drop that 5x. We get negative 3y equals negative 5x minus 3. And again, divide by that negative 3. Was that plus 1? Alright, so now that we got this, okay, let's go ahead and graph this red line. You can convert both and then graph. Some people like to solve one and then graph and then solve the other and graph. Let's go ahead and do this though. We got positive 3. Remember, we always start at our y-intercept. And then I got a positive, so I want to go up and to the right. Can I go up 5 and right 3? I cannot. So I need to do the opposite, which is down 5, 1, 2, 3, 4, 5, and then to the left 3. Remember, try and do both sides. Sometimes you might not be able to do one side, like in this case. Alright, so I'm going to graph that. Ooh, that is terrible. Let me fix that up. Boom. Alright, now let's go graph the green one. We start at positive 1. Can I go up 5? 1, 2, 3, 4. Cannot, so I got to do the opposite. 1, 2, 3, 4, 5. And then back 3. Alright, now I can do my green line. See if I can get that in one shot. Boom. Alright, so if we take a look, do they intersect? I mean, if these lines went on and on and on forever, we can tell that they do not. Visually, we can understand that they do not. I mean, maybe if you drew your lines crooked, it might look like they're going to intersect. So what we need to recall, if you guys have seen this before, if not, I'll talk about it a little bit here. Just remember, if your slope is the same, here I got a 5 over 3, here I also got a 5 over 3. We have the exact same slope, we just have different y-intercepts, and this is what we call parallel lines. And for a system of equations, when we got parallel lines, that means we're going to have what we call no solution. And that is because these lines will never intersect, so that means no combination of xy ordered pairs will give us true statements for both of these equations. And you can kind of tell already, like whatever you put in for x and whatever you put in for y, both of these expressions on the left are the same. There's no way we could get them to equal different things if we are plugging them in the same. Alright, so let's take a look at the next one. This is our other special case. This one's already in slope-intercept form. I'm just going to write that here and box it up just because I like writing. I got fantastic handwriting. If you haven't noticed, it's actually really good on paper. Here it's kind of to be desired, they would say. Let's see, green, yes. Okay, so we got negative 2x plus 3y equals negative 6. Okay, this case, I got a negative 2x, so I got to add a 2x. Okay, drop this 3y down. I got 2x minus 6. We're going to divide everything by a positive 3. That's going to give me y is equal to 2/3. Remember, always try and put that x out front. Don't leave it in the fraction like that. Negative 6 divided by 3 is a negative 2. Oh, take a look. What does this look like? Looks like this and this are exactly the same. So if we were to draw our line right here, we go up 2 to the right 3, right? Positive 2/3, down 2 and back 3. Let's go ahead and put this line in. And then if I were to do my green line, right, it'd be the exact same thing, right? So I'd have a dot here, I'd have a dot here, I'd have a dot here, and then I'd be drawing this line all over again, which in this case is kind of crooked. Okay, so these lines actually overlap entirely, okay? And if you haven't guessed already, okay, if we have the same line, what do you guys think? All real numbers. That means no matter what value we put, because they're the exact same equation. So anytime you see something like that, same line, we're going to have all real numbers. Parallel lines, we're going to have no solution. Okay, so that's pretty much it in a nutshell for linear equations. Let's try some of these linear inequalities. These ones we need to pay a little bit more attention to detail because we got things like this and we got things like this. So remember, you got to make sure that you're using the correct line. Okay, so let's go ahead and convert this. I'm going to walk this first one through and then I'm going to have you guys do the next one. So we got 4x minus y greater than 2. I'm going to drop this 4x. Then I get negative y greater than negative 4x plus 2. Remember, I got to divide by negative 1. And I'm going to get y. Don't forget, if you divide by negative, we got to flip that sign. So 4 over 1, it's going to be a positive 4x. And we got 2 divided by negative 1 for minus 2. All right. And then let's do this one. We got x minus y greater than negative 1 minus x, negative y greater than negative x minus 1. Boom, burning through this. Alright, we got y. Got to do that flip. Negative over negative is going to be a positive x. Negative 1 over negative 1 is a positive 1. Alright, so boom and boom. Alright, let's go ahead and graph this red line. We got negative 2 is my starting point on the y-axis. I got a slope of 4 over 1. 1, 2, 3, 4 over 1. Can we go up? 1, 2, 3. Can't. 1, 2, 3. Can't even go the other way. Alright, take a look at our sign. What kind of line were you going to use? Dotted or solid? Looks like a dotted or dashed line. Make sure you're using the correct line. Okay, but we also need to do this shading, remember, because this is a inequality. So let's take a look. I'm gonna do this red one in purple. So we want less than. So what is a value less than negative 2 on the y-axis? that would be -3. So that means I need to shade this section right here. Alright. Kind of colored out of the lines, but no biggie, you get the point. Let me just fill this in. Alright, looks good. Okay, now let's go ahead and graph this other one. We got +1, and then our slope is also positive, so we're going to go up 1, over 1. You see how they crossed already? I met up with that line. That is exactly what I'm looking for. So these ones will have an intersection, but we are not looking at the intersected point. We are looking at the overlapping region. Okay, so also, what kind of line do I got? I got a dashed line. So let me do that. And then I want to do my shading also. Let's pull that up here. I'll do this green. So I'm looking for less than as well. So a value less than 1. That would be somewhere here. Okay, and I am trying to shade all the way below this line. I didn't expect for that to come out black, but that's alright. It's actually very distinct. Alright. So when you go through these, when these ones have these overlap solutions and they're not our special cases, take a look. We're going to have a portion here that is just green. We have a portion here that is just purple. And this is that purple and green together. So this whole section right here is what I'm looking for in my solution. This is the shaded overlap that represents all of our solution sets. All right, go ahead, pause the video here. I'm going to have you crank out the next one by yourself. Come back, take a look, see how you did. All right, welcome back. I went ahead and didn't shade it for you for one particular reason. I'm hoping you got the conversion to slope intercept form correct and your lines look correct. Looks like the lines, whoops, I should have used a solid line. Let's go ahead and do that. See, if you're not careful, you might put the wrong line. Okay, so here we're intersecting around 1, 2, and the reason I didn't shade is because if you're not using highlighters or colored pencils and you can distinctly see the different color in the shaded overlap, there's a way you could do this. Excuse me. If you're just using your regular pencils. So let's go ahead and look at our red line right here. Okay, so we want greater than or equal to, okay, and this one started at -1. So what is a value greater than or equal to -1? That could be 0, could be 1. So I'm going to go this direction on this line. So if you want, you could do little cross hatches, right? Let's say I'm coloring all this section here. Okay, maybe make yours look a little nicer. Mine aren't straight, but you get the picture. Okay, so I'm just drawing these lines here. Okay, so I got everything above that line. Okay, I'm going to still do this in red because if you're just using pencil only, you're only going to have the one color. But here I'm looking for a value greater than or equal to +3. So what would be greater than or equal to +3? That could be +4. Okay. So then here I might want to do something in the opposite direction, which could be something like this. Okay, and you see how only some of these lines on this section have this cross-hatched pattern. So this would be the section we're looking for, and then maybe you might want to fill that in nice and dark so it's easily identifiable. So you can do that using a little bit of different types of patterns. Figure out what works best for you. Alright, so on to the last part. We got 3 different examples here, special cases. I'm gonna have you. I'm gonna pause the video here and just do all these conversions real quick, so it doesn't eat up too much of your time. Come back, make sure you got these correct, and then I'll do the graph part and we'll talk about it. All right, welcome back. So I went ahead and converted all of these to slope-intercept form. So maybe pause it here again and take a look. Make sure you got everything correct and your lines look like they're in the same place. These are almost very similar. We got two sets of parallel lines here, but we got a different case for each one. So if we take a look at this first one, okay, I'm going to use yellow and green here so we don't get that black overlap. But this first one, so we got the red line, +3. This is saying greater than. So a value greater than +3 is going to be +4. So that means we're going to be shading this side of the line, okay? Then, if we take a look at the other one, y is less than, and we got 3x minus 1. So if I'm doing less than 1, that could be like 2. That would be this side of the line here, okay? If I'm shading either of these sides like this, does it look like any of these colors are ever going to overlap? No, they are not, because we got this middle section here. This one is going this way, this one is going this way. So these are actually not even going to intersect or overlap, I should say. So with that being the case, okay, I'm just erasing this so it looks nice for our notes. You know, maybe shade lightly when you do this. What happens if we don't have an overlap? So maybe we'll write something like this. If we got no overlap, then we're going to have what kind of solution? You guessed it, no solution. Okay, so this is something to remember. If the shaded regions, the half planes, don't overlap, then we're going to end up with no solution. All right, so let's go to this next one. We got this first one, y is greater than, and we got this -3. So -3 greater than -3 would be -2. So I'm covering all of this right here. Boom, boom, boom. All right. Oh, that's ugly. Okay, so that looks all right. We're good to go. That's for my red line. And then now for my green line, I want y is less than the one starting at +2. What is the value less than +2? That would be +1. So I want everything below this shaded line. That's not going to help me. We're going to have to do a different color. Blue. There we go. That's going to make a difference. So I'm shading everything below this green line, which, as you can see, our shaded region, our solution set, is going to be where? Between these two lines, you guessed it. So when we have something cover the entire graph like that, like here we had the parallel lines, sometimes we're going to have no solution because they're going opposite directions, and then, well, away from each other, I should say. On this one, they're going towards the other lines, and we overlap in the middle. Okay, so this middle section right here, let me draw it out for you. Maybe I'll trace it in black. This whole section right here, this is where our solution set is, this middle section. All right, so that was one of the other special cases, and then the other one we have, this last one here looks a little bit different. Go ahead, pause the video. I'm gonna crank out the conversion for you real quick here on the side, and then come on back. All right, welcome back. This is what I got. Again, we have another set of parallel lines here. Let's take a look at this red one. This is the one starting at +3. So this is saying y is less than, so +3 less than could be like +2. Okay, I'm gonna color this whole piece under this red line right here. Okay, remember I'm coloring everything below the line, just like so. think that looks good. Okay, now if we do the other one at positive 2, value less than positive 2 would be positive 1. Oh. Let's, you know what, let's do purple. What's with these colors? How about this peach color I got? There we go. So value less than positive 2 would be 1. And then we are getting everything down below this line right here. That's strange. Okay, anyhow, so if we look below this first one, there is this gap of space where there is no overlap. The actual overlap is everything below our second inequality right here. So the way that we would want to represent this, this would only be the overlap right here. We would want to indicate that all of this section here is overlap. So another way that we could color this, let me erase and show you guys how it would look if we are, can I do this? There we go, that saved a little bit of time. We know that this section right here does not need to be colored. We are actually really only looking for this section here. Okay, so be very careful about these special case scenarios. Make sure that your overlaps are correct. Remember, you can check to see if your solutions are correct. Okay? Pick a point, any point on the graph that you know should not be colored. Maybe we could pick this value right here, which would be -1, 3. Try plugging those in. It should not work for both systems. But if you use any of these values down here, they will give you a true statement. All right, I do apologize for the long video. 27 minutes right now. I know that's kind of long, but hopefully it's very helpful to you. These are the kind of things you're going to be seeing. Let's do some actual practice. Remember, if you can't get help from the video, ask a friend, ask a family member, somebody around you. Somebody's got to know something. I guarantee it. All right, well, I hope you enjoyed it. I'm going to catch you on the next one. Be easy. All right, peace out.